Across the vast landscapes of ancient America, from the dense jungles of Central America to the soaring peaks of the Andes, civilizations left behind structures that defy imagination. Towering pyramids rise from the mist, terraces cling to impossible cliffs, and cities unfold with precision that challenges modern understanding. These are not mere ruins. They are monuments to ingenuity, evidence of societies that mastered engineering, architecture, and astronomy long before modern tools existed. The Maya, Aztec, and Inca, among other pre-Columbian civilizations, designed temples aligned with the stars, aqueducts that carried water across miles, and roads that traversed mountains, deserts, and jungles. They accomplished feats that would confound even today's engineers, shaping massive stones, managing water, and creating cities in harmony with both terrain and cosmos. Yet the methods behind these achievements remain shrouded in mystery. How did they transport enormous stones without wheels or draft animals? How did they calculate alignments so precise that shadows and solstices transform pyramids into cosmic spectacles? In this documentary, we journey into the heart of ancient American ingenuity, exploring monumental structures, astonishing techniques, and enduring mysteries that continue to awe and inspire, revealing civilizations whose genius resonates across millennia. To understand the astonishing engineering feats of ancient America, we must first meet the civilizations that conceived them. Societies whose knowledge, ambition, and ingenuity transformed the landscapes they inhabited into living testaments of human achievement. Each culture left a distinct imprint on the continent, yet all shared a profound understanding of engineering, urban planning, and astronomy that continues to intrigue scholars today. In the tropical lowlands of present-day Mexico, Guatemala, Belize, and Honduras, the Maya civilization flourished for over a millennium. From around 2000 BCE to the arrival of the Spanish in the 16th century, the Maya built towering stone cities that rose above the dense jungle canopy. Cities like Tikal, Copan, and Palenque were not merely clusters of buildings. They were intricately planned centers of political, religious, and scientific activity. The Maya were master astronomers and mathematicians. Their observatories, such as El Caracol in Chichen Itza, allowed them to track the movements of planets and stars with stunning accuracy. Temples and pyramids were often aligned with celestial events, demonstrating a sophisticated understanding of geometry and the cosmos. Beyond their astronomical knowledge, the Maya excelled in hydraulic engineering. They constructed reservoirs, canals, and cisterns to manage water in areas prone to seasonal droughts, turning their cities into marvels of self-sufficiency and resilience. Every plaza, pyramid, and causeway was a reflection of meticulous planning, blending function with spiritual and symbolic meaning. Far to the north, in the heart of the Valley of Mexico, the Aztecs rose to prominence in the 14th and 15th centuries. At the center of their empire lay Tenochtitlan, a city that seemed almost otherworldly. Built on an island in the middle of Lake Texcoco, Tenochtitlan required ingenuity of the highest order. The Aztecs engineered causeways and canals to connect their floating city to the mainland, while aqueducts delivered fresh water across vast distances. The Great Pyramid of Tenochtitlan, dedicated to Huitzilopochtli and Tlaloc, was a symbol of religious devotion and technological prowess. The Aztecs combined stone and earth in monumental constructions, creating structures that could withstand seismic activity while serving ceremonial, administrative, and military functions. Their urban planning reflected an intimate understanding of human needs, trade, and defense, an impressive feat for a civilization operating without iron or wheeled transport. Journeying west to the rugged Andean highlands, the Inca Empire stretched over 2,500 miles, encompassing mountains, deserts, and valleys. The Inca transformed this formidable terrain into a network of roads, terraces, and cities that connected the empire from Quito to Santiago. Machu Picchu, perched dramatically on a mountainside, remains one of the most iconic symbols of Inca engineering. Its terraces, stairways, and water channels reflect a mastery of stone masonry and environmental adaptation. The Inca constructed walls with stones so precisely cut that not even a blade of grass could fit between them. Their road system, the Capac-An, traversed some of the most challenging landscapes on Earth, incorporating suspension bridges and switchbacks that made trade, communication, and military mobilization possible across immense distances. Their achievements were not limited to physical infrastructure. They also developed complex systems of record-keeping, agriculture, and administration that relied on ingenuity and practical knowledge rather than written language. Beyond the Maya, Aztec, and Inca, countless other pre-Columbian societies contributed to the continent's rich engineering heritage. The Olmec, often called the mother culture of Mesoamerica, carved colossal stone heads that weighed tens of tons, transported over long distances without wheeled vehicles. The Zapotec developed urban centers like Monte Alban with precise planning, terraces, and defensive structures. In North America, the Mississippian culture built massive earthen mounds, such as those at Cahokia, creating ceremonial and civic centers that reflected sophisticated social organization and architectural planning. Even in regions considered remote or inhospitable, these societies demonstrated unparalleled adaptation and innovation. They harnessed local materials, manipulated water flow, and constructed fortifications and sacred spaces that aligned with both geography and the stars. Each civilization left behind not only monuments, but also questions. Questions about knowledge, skill, and the human spirit's capacity to shape the natural world in extraordinary ways. Across the jungles, mountains, deserts, and plains of ancient America, a common thread emerges. These civilizations, separated by geography and culture, shared a remarkable ability to conceive, design, and execute engineering feats that continue to astonish us today. Their legacies endure in stone and earth, silently challenging our assumptions about what is possible and hinting at mysteries that may never be fully solved. And yet, for all we know, this is just the beginning. Hidden within the ruins, beneath layers of soil and vegetation, lie secrets that may reveal entirely new dimensions of ancient engineering. Wonders that may forever change our understanding of these lost civilizations. The landscapes of ancient America are punctuated with structures that challenge imagination and defy conventional understanding. From jagged pyramids rising from dense jungles to terraces clinging to Andean cliffs, these architectural marvels were more than mere buildings. They were expressions of power, spirituality, and scientific mastery. Each stone, each pathway, and each carefully aligned structure tells a story of societies capable of shaping their environment with astonishing precision. Perhaps the most iconic symbols of ancient American engineering are the temples and pyramids scattered across Mesoamerica and the Andes. In Guatemala, the pyramid of La Danta at El Mirador dominates the landscape. Rising 236 feet above the jungle floor and encompassing an astonishing volume larger than Egypt's Great Pyramid of Giza, La Danta is a monument of vision and determination. Its construction required immense organization, sophisticated knowledge of load distribution, and the movement of countless tons of earth and stone, all without the wheel or draft animals. Similarly, the Maya built step pyramids with precision that aligned with celestial events, such as solstices and equinoxes. The Temple of Kukulkan at Chichen Itza, with its shadow-casting staircase, transforms the rising sun into the mythical serpent during the equinox, a spectacular blend of architecture, astronomy, and artistry. These structures were more than ceremonial centers. They were instruments of knowledge, power, and cultural identity, reflecting a civilization that fused science with spirituality. In the highlands of Peru, Inca architecture reached unparalleled heights of durability and sophistication. Machu Picchu, perched on a narrow ridge above the Urubamba River, is a masterpiece of terrace farming, water management, and stone masonry. Each block of granite was shaped to fit perfectly with its neighbors, forming walls capable of withstanding earthquakes that would crumble ordinary structures. Inca engineers understood the forces of nature and harnessed them, designing their buildings to survive centuries of seismic activity, a feat still admired by modern engineers. The ingenuity of ancient American engineering extended far beyond temples and pyramids. Water, the lifeblood of any civilization, was carefully managed through aqueducts, canals, and reservoirs. The Aztecs transformed the marshes of Lake Texcoco into a thriving metropolis, with an intricate system of aqueducts that transported fresh water across miles of lake and causeways. These aqueducts were marvels of hydraulic engineering, demonstrating a keen understanding of gravity, pressure, and material science. In the Andes, the Inca constructed an extraordinary network of roads spanning over 25,000 miles, linking remote mountain communities with the empire's centers. The Kapak Hien traversed deserts, rivers, and sheer cliffs, incorporating suspension bridges made of braided fiber that could bear the weight of men, animals, and cargo. Roads were paved, terraced, and reinforced in ways that minimized erosion and maximized stability, reflecting careful planning and intimate knowledge of the land. Through these roads, armies could mobilize, messengers could deliver information, and trade flourished across vast, often hostile landscapes. The cities themselves reflect a level of planning that rivals modern urban design. Teotihuacan, located in the Valley of Mexico, is a testament to geometric precision. The city's central avenue, the Avenue of the Dead, stretches over 2 miles, flanked by pyramids, plazas, and residential compounds arranged in a grid-like pattern. Its layout reveals not only practical knowledge of transportation and defense, but also a symbolic alignment with the cosmos, suggesting that urban planning was a reflection of both earthly needs and celestial order. In the Andean highlands, Inca cities like Cusco were carefully integrated with the natural landscape. Terraces, canals, and buildings were arranged to optimize sunlight, water flow, and agricultural productivity. Sacred spaces were positioned according to astronomical phenomena, creating cities that were simultaneously functional, sustainable, and spiritually resonant. Even the placement of individual stones in terraces and walls shows deliberate intent, marrying engineering with artistry in ways that are difficult to replicate even today. These architectural feats are not just remnants of a bygone era. They are silent teachers, revealing lessons in ingenuity, resourcefulness, and harmony with the environment. The sheer scale, precision, and complexity of these constructions pose enduring questions. How did these civilizations plan, organize, and execute projects of such magnitude without modern tools? How did they achieve such precision in alignment, material shaping, and urban layout? As we wander among the pyramids, trace the roots of ancient aqueducts, and stand atop terraces that cling precariously to mountain slopes, we are confronted by an almost supernatural sense of skill and vision. Every stone seems to whisper secrets of engineering knowledge lost to time. Every road, every canal, every city plan is a testament to human creativity stretched to its limits. And yet, for all that has been uncovered, the full extent of their mastery and the methods behind it remains tantalizingly out of reach. The mystery deepens with each discovery, leaving us to ponder, could there be even greater marvels still hidden, lying beneath layers of soil, waiting to reveal secrets that might redefine our understanding of ancient American engineering forever? The grandeur of ancient American architecture was not born from chance. It was the product of knowledge, skill, and an intimate understanding of nature. Behind the soaring pyramids, the meticulously aligned temples, and the sprawling cities lay a toolkit of innovations. Techniques honed over centuries, combining observation, experimentation, and ingenuity. These civilizations transformed stone, earth, and water into enduring monuments, often without the technologies we take for granted today. Unlike old-world civilizations, many ancient American societies did not have widespread access to metal tools. Iron was unknown, and the wheel was rarely applied to construction. Yet their achievements are breathtaking. The Maya and Aztecs used stone hammers, chisels, and wooden mallets to shape massive blocks of limestone and volcanic rock. Obsidian, prized for its sharpness, became an essential cutting tool, allowing them to carve intricate reliefs and perfectly smooth surfaces. In the Andes, the Inca employed bronze tools and a combination of stone, wood, and rope to manipulate gigantic granite blocks. Stones weighing several tons were quarried, transported, and shaped with astonishing precision. The Inca developed methods of softening rock surfaces using controlled heating and cooling, allowing the stone to crack naturally along desired lines. These techniques, passed down through generations, illustrate an empirical understanding of materials that rivals modern construction science. Beyond stones, materials like adobe, clay, and mortar played a central role. While some cities relied heavily on carved stone, others used bricks molded from sun-baked clay reinforced by timber frameworks. The ingenuity lay not only in the materials chosen, but in their application. Terraces built on mountain slopes required precise layering of stone and soil to prevent erosion, while aqueducts and canals were carefully lined to resist water damage over centuries. The precision of these ancient structures suggests that these civilizations mastered surveying long before modern instruments existed. The Maya, for instance, aligned their pyramids and observatories with solstices and equinoxes, implying an advanced understanding of astronomy and geometry. They employed sighting instruments, plumb lines, and rudimentary leveling tools to achieve perfect alignments, ensuring that their buildings were both functional and symbolic. In the Andes, Inca engineers contoured terraces to follow natural slopes, directing water flow and minimizing soil erosion. They understood principles of hydraulics, employing subtle gradients in aqueducts and channels to transport water across mountains and valleys without pumps or metal pipes. Roads were plotted with remarkable foresight, avoiding unstable terrain and incorporating stone stairways and retaining walls where needed. These surveying practices demonstrate that ancient American engineers possessed not only practical know-how, but also theoretical grasp of spatial relationships that allowed them to envision and execute projects on unprecedented scales. Perhaps the most astonishing aspect of ancient American engineering lies in their construction techniques. The Inca perfected a method called ashlar masonry, in which stones were cut to fit together with such precision that not even a knife blade could slip between them. These walls were resilient to earthquakes, as the irregular shapes of the stones and their careful interlocking allowed structures to absorb seismic shocks. In coastal and jungle regions, the Maya employed corbelled arches to span large interior spaces, creating grand chambers that remained stable centuries later. The transportation of massive stones posed another challenge. Scholars have debated the methods by which Olmec colossal heads and Inca monoliths were moved across difficult terrain. Evidence suggests a combination of manpower, ropes, wooden rollers, sledges, and possibly water lubrication techniques. In some cases, stones were shaped at the quarry to minimize weight before being transported, demonstrating foresight and meticulous planning. Even more astonishing was the integration of engineering with environmental adaptation. Terraces on mountain slopes served both agricultural and structural purposes, stabilizing steep terrain while increasing arable land. Canals and reservoirs managed seasonal rainfall, preventing floods and storing water for droughts. Cities like Teotihuacan and Tenochtitlan integrated urban design with natural waterways, ensuring efficient drainage, sanitation, and transportation. These innovations highlight a profound principle. Ancient American engineers were not merely builders, they were visionaries who understood the synergy between material, environment, and human need. Their techniques were a sophisticated dance between observation, experimentation, and tradition, creating structures that have survived centuries of natural and human upheaval. Religion permeated every aspect of ancient American life. Temples, pyramids, and ceremonial centers were designed not only as places of worship, but as stages where the movements of the cosmos intersected with human ritual. The Maya, for instance, aligned their pyramids with solstices and equinoxes. The Temple of Kukulcan at Chichen Itza transforms with the rising sun, casting shadows that resemble a serpent descending the staircase, a spectacular manifestation of celestial events encoded into stone. For the Aztecs, the Great Pyramid of Tenochtitlan symbolized both spiritual devotion and cosmic order. Its terraces and platforms were dedicated to gods, serving as sites for intricate rituals that reinforced social hierarchy and divine authority. Similarly, Inca sacred spaces, such as the Temple of the Sun in Cusco, were aligned with solar events, connecting earthly activity to the movement of the heavens. These structures were observatories, altars, and calendars all at once, allowing these civilizations to predict seasons, manage agriculture, and honor their deities with astonishing precision. Engineering was also a tool of control, defense, and societal cohesion. The layout of cities, fortifications, and roads was carefully planned to protect populations, facilitate communication, and support military operations. In the Andes, the Inca constructed fortress-like structures such as Sacsayhuaman, whose massive stone walls were nearly impenetrable. Their road system allowed rapid deployment of troops across mountains and valleys, ensuring the empire could respond swiftly to threats. Similarly, the Maya and Aztecs designed urban centers with strategic considerations. Elevated pyramids served as watch points, while causeways and canals could control access to key areas. Beyond defense, engineering reinforced societal order. Aqueducts, reservoirs, and terraces ensured food and water distribution, sustaining large populations in challenging environments. Administrative centers and plazas centralized governance, commerce, and religion, creating societies that were remarkably efficient and resilient despite lacking modern technology. These dual purposes, spiritual and practical, demonstrate a level of integration rarely seen in human history. Every structure was multifunctional. Temples were astronomical observatories. Roads were trade and military arteries. Terraces stabilized mountainsides while producing crops. The line between sacred and functional blurred, revealing civilizations that understood the interdependence of belief, survival, and environmental mastery. As we trace these ancient constructions, it becomes clear that engineering in ancient America was never arbitrary. It was purposeful, deliberate, and astonishingly sophisticated. Yet despite the evidence of careful planning, meticulous execution, and deep understanding of both nature and society, the precise methods by which these civilizations achieved such integration remain a tantalizing mystery, a riddle etched in stone, awaiting those bold enough to unravel it. From the jungles of Central America to the peaks of the Andes, archaeologists have uncovered sprawling cities and monumental architecture that continue to defy explanation. At Tikal, Guatemala, towering pyramids rise above the forest canopy, revealing complex networks of plazas, reservoirs, and causeways meticulously designed to sustain thousands of inhabitants. Excavations of these pyramids have uncovered not only staircases and chambers, but also evidence of advanced construction techniques. Precisely cut limestone blocks, terraced platforms, and drainage systems that managed seasonal rainfall. In Mexico, the discovery of Teotihuacan revealed a city carefully aligned with astronomical phenomena. Its massive Avenue of the Dead, flanked by the Pyramid of the Sun and Pyramid of the Moon, showcases urban planning that balances scale, symmetry, and celestial orientation. In the Andean highlands, Machu Picchu offers perhaps the most dramatic evidence of engineering excellence. Excavations have exposed terraces carved into steep cliffs, stone structures fitted without mortar, and sophisticated water management systems, all harmoniously integrated with the natural landscape. Beyond architecture, entire networks of roads, aqueducts, and fortresses have been uncovered. The Inca Capac Yan, stretching over 25,000 miles, reveals a civilization capable of uniting diverse terrains and communities through infrastructure. Archaeological digs along these routes have unearthed stone bridges, way stations, and signaling systems, demonstrating foresight and precision in planning that rivals any modern engineering project. Physical structures are only part of the story. Inscriptions, codices, and artifacts provide deeper insight into the minds of these ancient engineers. The Maya left behind stelae, carved monuments that record the reigns of kings, astronomical events, and societal achievements. The Dresden Codex, one of the few surviving Maya manuscripts, offers detailed records of celestial cycles, eclipses, and planetary movements, suggesting that architecture and astronomy were deeply intertwined. Artifacts such as obsidian cutting tools, bronze implements, and carved stones reveal the practical knowledge these civilizations employed in construction. Even decorative elements, such as reliefs on temple walls, often contain geometric patterns and alignments that hint at sophisticated understanding of measurement and proportion. Olmec colossal heads, carved from massive basalt boulders and transported over long distances, are a testament to both artistry and engineering ingenuity. Together, these discoveries form a narrative of civilizations capable of extraordinary technical achievement. Yet despite decades of research, many questions remain unanswered. How did societies without metal tools or written blueprints execute such precise constructions? What techniques allowed them to manipulate enormous stones, manage water, and design cities that harmonized with both environment and cosmos? Each dig, each artifact, each inscription adds another layer to a puzzle that continues to captivate archaeologists, historians, and engineers alike. Beneath the jungle canopy, the Andean cliffs, and the arid plains, ancient America still whispers its secrets, daring us to uncover the full scope of human ingenuity that shaped a continent long before the modern era. Take, for instance, the Inca walls of Sacsayhuaman, where stones weighing tens of tons interlock perfectly, some shaped to fit like puzzle pieces without the aid of mortar. The precision is so exact that even today, it is nearly impossible to slip a knife blade between them. In Machu Picchu, terraces cling to steep mountainsides, designed to prevent erosion while channeling rainwater, a feat of environmental engineering that surpasses many modern techniques. In Mesoamerica, Maya pyramids and Aztec temples align with astronomical events with extraordinary accuracy. The Temple of Kukulkan, for example, transforms during equinoxes into a descending serpent of shadow and light, a complex interaction of geometry, solar movement, and design. The level of mathematical, astronomical, and engineering knowledge required to achieve such effects is staggering, especially without written blueprints or instruments like modern theodolites or laser levels. Even the transportation of enormous stones presents an enduring mystery. Olmec colossal heads, some weighing over 20 tons, were moved from distant quarries to ceremonial centers hundreds of miles away, likely using human labor, wooden sledges, and possibly rolling logs or water-assisted techniques. Yet the sheer scale of these operations continues to puzzle scholars. How could societies without draft animals or wheels coordinate such massive projects with such precision? Scholars and enthusiasts have proposed a range of explanations. Some suggest the use of ingenious mechanical techniques such as levers, ramps, and sledges, combined with careful planning and trial and error. Others point to a cumulative knowledge passed down orally over generations, refined to near perfection through centuries of experience. More speculative theories consider the possibility of lost knowledge, ancient techniques, now forgotten, that allowed these civilizations to manipulate stone and earth with surprising ease. Could they have developed advanced surveying methods using sightlines, plumb bobs, or simple water levels that, when combined with deep observation of natural forces, created results that appear almost supernatural to us today? Still, even with these theories, many questions remain unanswered. How did geographically isolated civilizations, such as the Maya in the jungle and the Inca in the high Andes, independently converge on sophisticated solutions to similar engineering challenges? How did they coordinate massive construction projects across vast and rugged terrains without modern communication tools? These mysteries invite us to rethink assumptions about human capability in the ancient world. Every perfectly fitted stone, every aligned pyramid, every enduring road and terrace challenges the notion that advanced engineering requires modern machinery. In ancient America, knowledge, creativity, and observation were tools as powerful as cranes and computers. The engineering marvels of ancient America did more than shape the landscapes of their time. They left a legacy that echoes across centuries, influencing cultures, inspiring awe, and challenging modern understanding of human capability. From the monumental pyramids of Mesoamerica to the terraces and roads of the Andes, these achievements remind us that ingenuity and vision can transcend tools, technology, and even time itself. The architectural and engineering accomplishments of the Maya, Aztec, Inca, and other pre-Columbian civilizations served as cornerstones for cultural identity and social cohesion. Cities like Teotihuacan, Tenochtitlan, and Machu Picchu were not only administrative and religious centers, they were symbols of power, intelligence, and the capacity of human societies to adapt to diverse and challenging environments. Their innovations in water management, agriculture, and urban planning provided practical solutions that sustained dense populations in regions that might otherwise have been inhospitable. These achievements also had profound symbolic and cultural significance. Temples aligned with solstices and equinoxes encoded astronomical knowledge into everyday life, influencing festivals, religious rituals, and agricultural cycles. Roads, bridges, and terraces were more than infrastructure. They were instruments of empire, weaving communities together while demonstrating the reach and organization of a civilization. Even today, echoes of these innovations persist. Modern cities in Mexico, Peru, and Central America often follow routes, plazas, or building layouts first designed by ancient planners. The artistry embedded in engineering, sculpted stones, carved reliefs, and monumental facades also continues to inspire. Artists, architects, and engineers study ancient sites not merely for historical interest, but for lessons in harmony, proportion, and integration with the environment. These structures remind us that engineering need not be purely functional. It can be an expression of culture, spirituality, and creativity, demonstrating a level of sophistication that resonates across millennia. Today, the preservation of these sites is a pressing concern. Machu Picchu, Chichen Itza, and Tenochtitlan's ruins face threats from natural erosion, tourism, and climate change. Archaeologists and conservationists work tirelessly to protect these treasures, balancing accessibility with preservation, ensuring that future generations can witness the ingenuity of civilizations that shaped the Americas long before modern technology existed. Beyond preservation, the relevance of ancient American engineering extends to modern urban planning, sustainable architecture, and environmental design. Terracing techniques, water management systems, and earthquake-resistant construction offer lessons in sustainability and adaptation. By studying the methods of these civilizations, engineers today can uncover strategies for building resilient infrastructure in challenging environments. Proof that ancient knowledge can inform modern solutions in ways previously unimagined. The legacy of ancient America is thus twofold. It is a testament to the heights human societies can achieve through vision, collaboration, and ingenuity. And it is a living guide, offering insights for contemporary engineering, architecture, and environmental management. These civilizations remind us that the genius of the past is not locked in stone. It continues to shape the present and inspire the future. And as we reflect on the enduring impact of these achievements, we are compelled to ask, what other lessons lie buried beneath the stones and terraces, waiting to guide us toward new horizons of understanding, creativity, and innovation? The civilizations of ancient America leave behind more than ruins. They leave a challenge to our imagination, a question of human potential. Across jungles, mountains, deserts, and valleys, the Maya, Aztec, Inca, and countless other societies carved a world that combined utility, beauty, and cosmic order. Their pyramids, terraces, temples, aqueducts, and roads were not merely constructions. They were statements of knowledge, devotion, and ingenuity that have endured centuries, defying the limitations of their era. What makes these achievements truly astonishing is not only their scale, but their precision. Structures aligned with the sun, the moon, and the stars. Stones fitted so perfectly that mortar was unnecessary. Cities designed to endure earthquakes, floods, and time itself, these feats continue to inspire awe and wonder. They are proof that human creativity, observation, and ingenuity can transcend the apparent limits of tools and technology. Yet amid all that has been uncovered, mysteries remain. How did societies without modern machinery move stones weighing tens of tons? How did they align massive structures with celestial events with such precision? Each unanswered question only deepens the fascination, suggesting that the full scope of ancient American engineering may never be fully revealed. As we stand in the shadow of these monumental achievements, we are reminded of the enduring legacy of human ambition and intellect. These civilizations teach us that innovation does not require modern technology. It requires vision, knowledge, and the courage to shape the world in harmony with nature and the cosmos.